Today, so you saw, I mean, don't take me too serious. Yeah, does not mean that I'm a doctor. You have to deal so very serious with me. We can interact. I'm not planning to have a very dry presentation. We will interact a lot. I will ask you questions to be always awake. It's very important. So as you know, why I selected this, or we selected this title for the presentation, because it's very important for engineers who would like to work on IoT to understand first the market. Yeah, because if you don't understand the market, you will not be able to create something which has a value. Yeah, so as an engineer, this is one of the pitfalls for engineers. Actually, they are too good in the technical stuff, but they know very less on the business, on the market, and so on. So what happens is that they go build something, and then they find, oh, it does not work. So that's why I would like to raise the awareness on IoT market, and then of course show the process for developing innovative products. So the main objectives of this presentation is to understand the IoT application sectors. I will mention the major ones here, and of course also to see get the feeling about the IoT market potential. So here we will see a lot of USD dollars, a lot of billions stuff. So it's something interesting. The next thing is to look at the IoT solution architecture. So from system perspective or from a solution perspective, what are the main core elements of IoT? Yeah, because this is very important. Some people think IoT is more embedded. Some people think no, IoT is more networking. So we will see the complete stack of what is IoT end to end. Yeah, and the last thing I think, which is from my point of view the most interesting part, is the product innovation process. So this is what brother Anas mentioned. Like, we need to work on the mindset, and the mindset of developing an IoT innovative product is quite different from traditional product development. So this is something which I will go through. I hope I have enough time. How much time? 45 minutes? 30 to 35. 30 to 40. Oh, so I have to speed up, man. Okay, so what is IoT? Just to make sure that we are all on the same level of understanding. Well, the basic definition is a network of physical objects that use or deploy sensors and APIs to collect and exchange data over the internet. Maybe I would like to add also to optimize a certain solution for a problem. Yeah. So this means it's mainly basic physical objects. This can be anything. Yeah. This can be anything. So this means here can be at home. It can be devices, appliances at home. Can be something related to camera, something related to the clock, something related to the airplane, and so on and so forth. So all these objects are connected to the network. So the question is why we need to go for IoT, because now people might think IoT is a buzzword, like everything connected and so on. What's the main purpose behind this? The main purpose is operational efficiency. So if you are in an industry, of course you would like to have this connectivity to make sure that you are always running, you don't have any delays. So if you are able that you get status always from the machines, for example, you have communication between the machines, you make sure that you have an optimal solution, you have more productive solution, you don't lose time, for example, if you have some kind of defects in the machines or something like that. So using this IoT, this is one of the examples. We will see now from the applications different examples. The main thing is the operational efficiency. Of course, there are other things. For example, this also influences the quality of service. For example, if you talk about healthcare or medical applications, of course, you can improve the quality of service, because then you can try to save more people, let's say, within a certain time. And of course, some applications might go down to the level of comfort. So it depends on the application and so on. But that's the main driver. So this is operational efficiency. So what are the IoT applications? Here we can see a lot of IoT applications. I will dig into details in some of them. But you can see, for example, just to list some. Of course, the connected car will be a very, very important application. Farming is one of the applications also, which is interesting. Home automation, and maybe also mention here again the healthcare and the building management. So all of these, and these are not all the applications, of course, but all those are the major applications. So let's take the connected car. Here there's a lot of applications. I will not discuss them, but I would like to pick maybe two of them. Yeah. For example, one of the things is like your driving behavior. If you have a lot of sensors in your car, your insurance company can see or model your driving behavior. This means that they can charge you maybe more or less. Yeah. Because for example, now currently you are all paying the same, but you can say, oh, I'm driving very good. Why do I need to drive to pay the same fees like somebody who is really, exceeding the speed limit? Yeah. So actually, by having IoT connected cars, because connected car is an IoT device at the end, the insurance companies, they get this data, they analyze, and they say, okay, you are really driving very well, so we can reduce the fees on you. Others can increase the fees, and so on. One of the other things, for example, which might be also interesting, the accident detection. When you make an accident currently, for example, if you go and buy another car, if the guy is honest, of course, you will know if he made an accident or not. But if he's not honest, then, of course, you don't have a clue. Yeah, maybe the mechanic can help you. But at the end of the day, if you have good sensors in your car, then you can also know that an accident happened, when it happened, and also you can get all the profile of the car, and then you make sure that you give the right value for the car before you buy it. This is one of the applications. Another application is very important is the Industry 4.0, which is actually the smart factory. Yeah? In Germany, we use Industry 4.0. In USA, they use smart factory. There are different, like terms for it. But at the end, what's important for the industrial application or industrial IoT is what are you doing? You are optimizing the supply chain via IoT. So when you have all the sensors here in your factory, they are connected. Then for example, if you have some materials that are missing or something like that indirectly, this connected to the supplier chain, connected to the logistics. For example, if in case some products are finished early or late, make sure that there's always some truck to pick them. Of course, you can also at the customer side, you can try to customize products and try to provide more value for customers. Yeah. So you don't need to provide, so you will have different variants of products where, for example, the customers can directly on the web try to customize their products and directly send the data to the factory to change the processes. Yeah, it's also a very valuable thing. This just shows one of the scenarios here. We have different things. I like this picture because it shows different technology within the Industry 4.0. So it shows here the smart automation part, which also, of course, automating all the machines and the sequence of them. You have, of course, here that you are communicating with the robots. Also, you will have this collaborative robots, they call them. They have, of course, you have also the monitoring and conditioning of the machines and the belts here running. So you have different things. So, but the main part is to optimize the productivity of the factory. Yeah. Optimize the productivity and reduce the delays and the latencies. For the healthcare, also you have different applications. Of course, the most important application is to monitor the patients, especially remotely, because, for example, sometimes you don't need to be in the hospital. You can just, have a sensor device and then go out to home, and then you can log the data, and then, of course, everything goes to the cloud, and the analytics will happen. So you have, of course, the device to analytics, and of course, very important, remote equipment configuration. For example, if you have a lot of equipment, the supplier can also configure these equipments directly from the cloud and maybe calibrate them, of course, or, for example, repair them. Yeah. And of course, in case you have any appliances, for example, or supplies, and it needs maintenance, also they can also, this could be one of the applications for this remote equipment configuration. So you can see even for hospitals, for medical centers, it's very important. I mean, there are some interesting applications there. Of course, here we are talking in general. It gets much nicer when you dig to the details and you understand what are the needs and how can I provide, an IoT product which they would like to pay for and so on. But this is the second part. So this one may be one of the scenarios. A person is here sitting, and of course he has some sensors for the blood pressure or another sensor. Even here, for example, you can see the bed is connected, and you can see the temperature of the bed. You can see the temperature of the person, because sometimes for some reason maybe the patient have problems, and then of course once you have more data, you can better analyze. You can know, for example, if he has cold, he needs more warm bed. You can control the heater in the bed itself, and then everything goes through the cloud or through the gateway. Depends. Another interesting real life scenario is in this case here, doctor is searching for an item. So he can also, of course, connect through, in this case, RFID reader, which sees all here the items, and he knows what he has, what kind of item is located in which room. Yeah, it's also not only for the patients, also for the staff themselves, because you have a lot of resources. You would like to track those resources. You would like to make sure that you, don't lose anything or not find something on the right time. So another application is smart homes. Of course, as you can see in the picture, everything related to smart home, any appliance, whether it's lights, let's say washing machine, everything could be connected. Of course, you don't have to connect everything, but it depends on the application. Yeah, depends on the use case which you would like to have. But theoretically or practically even, you can connect all those. Now, the main applications or the use cases in a smart home is energy management, because energy costs money. Of course, if you can reduce the energy or optimize the use of the energy, this is very good. You can reduce costs, of course, and then from here comes the smart lighting, and then of course the temperature control, and of course security is very, very important, talking about the safety here. So you can see some functions are very essential, like safety and security. Some others are more entertainment, comfort. So depends on the user, but all those are enabled by the Internet of Things. Here this shows a typical scenario. For example, you are at home. You could have control for these cameras. I don't know why this is inside the home, but can happen for some reason. You have also the spotlights. For example, you have the curtains. You have the smart TV. Maybe you have other appliances. But like you can control everything centrally from, let's say, one I don't know, iPhone or iPad or tablet in general. Even you can remote it within the home or even from outside the home remotely. For example, this I find this very interesting because they have this eco mode. For example, it can be that, for example, you leave the home, but once you leave the home, you don't to make sure that everything is turned off. You can maybe make a mode I'm leaving home. Then automatically everything will be turned off. Only the fridge, of course, very important. You can need to keep it on, but everything else could be turned off, whether it's the plugs or the lights and so on. This is also very good, so you don't forget anything, and of course you don't have any additional costs. In farming or in agriculture, so it's also quite interesting. So before, of course, we were based on physical machinery work. Now, I don't know if this is quite true. I feel it's too optimistic. The present, so they claim here that present there are some farmers, of course, depends on where you are, maybe using technology to track, what's going on the farm and try to optimize the process. But at the end of the day, IoT, what it enables, of course, with IoT you have more sensors on the plants and on the soil. You have sensors try to measure the condition of the soil itself, because this, of course, has a big impact on the crop itself. And of course, then also you have, for example, like weather conditions and water management system, and also you can also, for example, here use UAVs for to inspect something on the field. So you have more data. You try to understand more what's happening on your field, and then, of course, when you have all this data, you can make analytics and try to change conditions so that you can adapt yourself to improve productivity. Again, the main important thing is that you use IoT not for fun. You use IoT to reduce the costs. Otherwise, it does not make sense, because it costs money, right? So here this shows exactly the main use cases for farming. So here this is with drones, the field monitoring, you can see it. Soil erosion, because the soil can get corrupt or some problems, you have to put medicines, and you have to make diagnosis of maybe disease of some plants and so on. Maybe we are not aware of this because we are not farmers, but farmers, they know this. If they have any disease problem, they will lose a lot in a season. So it's very important. Of course, if somebody would like later on to do anything in this field, it's very important that you work closely to those people who who have the problems. Maybe I would like here also to mention that once I'm talking about the applications, try to imagine something. Try to think, if I would like maybe later on to come up with an IoT product or IoT idea, maybe it makes sense to do it in this field, maybe or that field. Try, because the main purpose of what I'm now showing all this, to give you the feeling, yeah, not just, you know, I have a network of IoT devices and so on, to give you the feeling that this IoT is a real stuff which will be applied in real life. In real life, and there's real problems. It's addressing real problems. So these are the problems which can be solved, let's say, with IoT. Exactly. So this was the last slide in the applications. So we have seen, let's say, the major applications in IoT. Yeah, of course, there are other applications. If you're talking, for example, about schools, about special organizations, you can always try to optimize something using data and using sensors and networks. Here I would like to show you the potential of the market. So, of course, many people working on marketing, they have made studies, analytics, because they want to understand, you know, is it like a fake thing, or we are going to, you know, have a big potential, we can spend, invest money, because investors will not invest money if they don't see a potential, yeah, you know, otherwise it does not make sense. So here all the data which you will see are based on the this report from Markets and Markets organization. So this is a market research organization, and it's relatively old, from 2016 to 2022, but I think it gives a good feeling on the different aspects of the market. First, it's important to understand that not every IoT is the same. Yeah, you have a big spectrum of IoT. Everything's IoT. Yeah. So what we need to know here, that we have the industrial IoT, we have the partial industrial IoT, and we have not industrial IoT. Everything related to consumer electronics, it's not industrial. So it's easier to deal with, like in the industry, yeah, because the conditions are not so strict like in the industry. People are, you know, like that's different. They are not losing money here, for example, compared to the industry. So partial industrial, like healthcare and retail and logistics, and there's a big thing here. And most of the things which we have mentioned are industrial, other than the healthcare. Partial industrial, for example, building automation, agriculture, and so on. So here, industrial, this means that you are mainly working more with organization, or mainly, but maybe there are some exceptions. So the first thing is important to see that they made the forecast, and this shows the a high growth ahead. This means a big market growth rate. So here we are talking about billions USD, worldwide, of course. So they are expecting for an exponential increase. This means that there will be a lot of money in the IoT sector, and for you as a person, or maybe as a team, or as an organization, there's a big potential if you came up with a good idea that you also get part of this share of this market, But even at 0.00, it will be a lot of millions. So don't hesitate. Exactly. So here this shows, in general, this is the compound annual growth rate. So this means from 2016 to 2022, you have 32.4%, which is 1/3. It's big, a lot. We reach here by 883 billion. So a lot of text here, but this also from the study. But what's important is here we will also see that the top, let's say, industries in IoT are automotive, building automation, industrial automation, or industrial IoT, let's say, or at the top. So here they also show the growth across technologies. So it's very interesting. They show not only the applications, but also the technologies. So how is the growth going to be on the hardware side, on the platform side, software solutions and services? And as you can see here, of course, if you compare software to hardware, the software is much more, and even the scaling at a very high rate. Higher rate, but this does not mean that it's here very less. It's here also something, but you can see because it's exponential going almost. So but of course software, for example, it might be that you come up with an idea, for example, it's more a software idea, does not have to be hardware, because people think IoT embedded. IoT is not only embedded is just a small part in IoT, or electronics or something. Maybe you provide an app, just an app. Maybe you provide, let's say, a service in a different way. Maybe you provide a service analytics, for example, and algorithms, maybe analytics, machine learning, AI, whatsoever. So you don't have to say, I would like to provide everything. If you can, and you have the right team, it's good. But at the end, you can see here, on each of those parts, there's a big potential. And it's important to know what you are doing. You have skills for it, and so on. So how's the market share for the applications? We say the top is the automotive. This was based on 2015. I think they will vary a little bit, but at the end of the day, I think they will be almost with the same proportions. So at that time, 19.2 for automotive, and the second comes directly industrial. Of course, now industry 4.0 is also a very interesting topic. So, and then afterwards come the building automation. So this is also very interesting because in case you are searching, maybe here you have more, if you have, let's say, the knowledge or the competency for more than one sector, then you say, okay, I have here maybe more chances for success because probably here it's much bigger share. What are the market dynamics? Of course, now IoT, there are also challenges. It's not just like something from one day to the next day. Are challenges which we are facing currently. So the main, maybe before going to this challenges or restraints, we have the drivers. The drivers, of course, why we are currently seeing more and more IoT products. More business models are based on IoT because, of course, the internet is getting. I mean, everybody has internet connection. It's widespread. Wherever you are, so wherever, university, homes, cafes, like go cafe. If you don't have a Wi-Fi, you go to another cafe. That's so actually everywhere, even in the ban. I'm going to the ban. So when there's no Wi-Fi, I feel I cannot work. That's a problem. But they also have Wi-Fi, so that's good for me. Of course, smartphones are everywhere. Everybody has smartphones. Unfortunately, but it's not good for children to give them smartphones. Not good. But if when they get old, it's good. So increasing adoption of wireless sensors. Of course, now most of the sensors, even if you buy a device, you see, okay, it has a Wi-Fi. It has a Bluetooth. So this enables its integration in the network. This is very good. And of course, they're now talking about cloud computing, talking about analytics and all this kind of algorithms. For example, even if you look now at the solutions from Microsoft, Amazon, they are driving very heavy in this direction. So they are providing a complete stack of cloud computing services. So most of the companies, enterprise clients, they buy service from those big giants. But still, there's room also for others to work. So it's not everything. So challenges are, of course, the low power efficiency of devices. So you need, of course, sensors to be 24, or maybe not 24, but always have a very long lifetime. So you don't want also, because they are wireless, you don't want to connect them to the power. They need to, be durable for a long time, have enough power for a long time, and so on. Maybe we can think here about energy harvesting or some other stuff, but this is one of the challenges, let's say. And of course, the security is a very big challenge, because everything is connected. You have a connected car, anything can happen, an attacker can get into the car, and it would be a big problem. So it's always like you have opportunities, but you have also challenges. It's always the same, whatever you are doing. Okay, so this shows here very interesting geographical share of the market, and it's very interesting to see here. There are two dots here, market share. In 2015, and this is the growth rate, compound annual growth rate. And very interesting to see that there's big investment, actually, big market share in the Asia, in Asia, because China, especially China, they are investing a lot, and probably most of you this interconnected cameras, cloud-based camera analytics of faces and so on the streets and so on. This is one very interesting example of IoT. Very interesting example of IoT. They use it for, I don't know what, but probably for security, for security applications. So let's see. Europe and USA are almost developing step by step. Probably here, of course, much less, because here we have more industries and so on. But it's very interesting. This is a very interesting point here to see. And the growth here, it's also actually 8.9 is good. Here is also actually very high growth still. So actually, that's why actually, if you would like later on to make something, of course, maybe you can start locally, but you have to think about the whole world, because you are not alone. Given now globalization, you can sell everything on Amazon, you can sell everything on eBay or whatsoever. You can have a channel, you can sell everywhere. If you have a standard product which fulfills the requirements, let's say European requirements or the other continent which you are selling, you can do it. So it's good to think globally. Yeah. So now we get to a bit technically. Yeah. The IoT solution architecture, I would call it. So, what are the major components of an IoT solution? I would say we have the devices. Yeah, devices are all the sensors, actuators connected, even the gateways. Now, the gateway can also be combined with an edge. Now I'm talking about the edge. Edge is mainly a processing node which is responsible for pre-processing, for filtering of data before sending it to the cloud. Yeah, they call it edge computing. Edge computing is very important because especially if you have time-sensitive applications, because you don't want to send it to the cloud and make the decision and come again. Yeah, especially if you are in a car, for example, you want to make fast decisions, then you need to have an edge processor here or an edge node. Yeah, and then you have the cloud where you have the analytics on the cloud. Cloud means the server. Yeah, it's not cloud just a fancy word for a server, so it's not something big. So of course, infrastructure, a big infrastructure of servers maybe, and database and so on. But what do you do on the cloud? Mainly you have, of course, dashboards. You can directly connect the cloud. You have the dashboards, all the analytics, and you see what's going on, the status, the monitoring, and so on. You can make analytics and predictive modeling, see what's, for example, in the case of Industry 4.0, predictive maintenance. If you have in a factory, you have machines which are expected to get defect in the next 2 weeks, then you know beforehand because you have this predictive modeling. Then what you do, you plan it beforehand so that you don't lose time at the end. This is very important application in Industry 4.0. And of course you have the applications. So here we see the thing or the device. This is local area network, mainly connected with the gateway. Some people call it IoT hub whatsoever. And you can combine it with the edge. There's no currently like unified architecture. Yeah, they are different, depends on your application, depends. But I tried to show you here the mainstream. Yeah, and so here you can have a gateway and can have an edge also. Yeah, you can have only one gateway which combines both depending on the hardware itself. But you have, of course, the cloud, and within the cloud, then you have the analytics, and then, of course, you have a user interface, let's say more here, the application, which you have on your smartphone or on your tablet and so on. So these are the main components. I like this slide because it shows really the main components, and if you'd like to make something in the future, you need to think, maybe where, you have an idea maybe, and then you think, okay, where is my idea fitting? Is it fitting more here? I'm a good app developer, for example. I can make something here. But of course I have to make sure that it also have a good compatibility with everything else. If I'm maybe making more hardware, maybe I can make a gateway, for example, whatsoever. So it depends. Core technologies, so this means that we have very important core technologies in IoT, yeah, very important. Of course, embedded sensors and actuators, here embedded system engineers are very interesting for embedded system engineers because they have a big potential, of course, in terms of jobs, in terms of making even ideas and realizing them. Of course, connectivity and networking. Yeah, so networking is very, very important. Connecting, local as a local network, as a global network, and of course, security is very, very important. Whether it's on the embedded level or even at the cyber security level, like on the networking level, cyber security, very important. So, and of course, data analytics and machine learning is very important on the analytics part. And providing a software platform, like for example what Microsoft and Amazon are doing, and Google, complete platform, maybe it could be also maybe limited platform whatsoever, and services. Yeah, these are very important core technologies. And maybe even, for example, if somebody is studying and he would like at the end to maybe focus on something in his master. How many of you are students here? Can I ask a question? Great. Okay. So if some of you are, for example, mainly more into electrical and computer engineering, they can, does not mean that mechanical, there's nothing, we're just focusing on the electrical and computer engineering. But for example, sometimes in your thesis, you can maybe focus on one topic. So it might be interesting for you to know, for example, if one of those topics, it's addressed by your thesis, is also interesting because, okay, it helps me later on to be, do something in the direction of IoT. Okay, so very fast here, we have the cloud integration. We started from here. We have the device connectivity. We have here local communication standards connecting with the edge. Here we call it edge. It's the gateway and the edge, I would call it. Then which actually controls and collects the data and controls even those devices on the local level, and performance monitoring services. So depends on the application as well. But this is, let's say, end-to-end architecture. Here also this shows a different view, call it the core subsystem. We have the IoT devices. The device management works on this level with the cloud gateway IoT hub. It's a gateway to the cloud, and it's also at the same time an IoT hub. And of course stores the data. Then here more we are on the cloud. Yeah, we have a data storage. Then and of course you are doing the processing of the data, and also then you are generating reports, graphical data visualization and all these kind of things. And actions here, they provide also business integration. Then you can also provide your own applications. So you have APIs, you can get all this data, all these services, even the analytics, and then you can build on top of them your applications to make something special for you. So what, for example, maybe this is one a bit more detailed. Exactly. So here, what this, I guess this was from Cloudera or exactly. So or even for example from Amazon and so on. So what they provide for you is they provide enterprise till here, and then they provide APIs to you. Yeah. So you can actually connect the devices here, and then they provide you with the complete stack or chain of nodes and services. And then here they can give you really APIs and tools so that you can build on top of that your applications, which make use of their analytics algorithms and all these kind of things. But I like this picture because it gives you very interesting and detailed view on all the phases almost, and what you can do in each phase. I will not go through them because that will take time. What I want also to raise awareness here is on the wireless standards. So we have a local network, we have a global network. Depends where you are. If you are within one building, within one, let's say, one room or one floor, you can use short-term communication, short-range communication. If you are getting bigger, of course, on a campus level and so on, you need different kind of communication. Usually here it's local area network, personal area network is really very personal, so it's even narrower range. Here we are talking about the wireless wide area network, and here's for low power wide area network. This is new for IoT currently because they don't want to transfer a lot of data, transfer just the most important data, status messages or let's say signals. So they don't need to spend that much money for the LTE. So they came out with, for example, a narrowband IoT. It's a new standard protocol, and even LTE-M and LoRa and so on. So these also you can achieve with this at low cost and low power wide area network or data transmission. As you can see here, for the local, let's say local and personal, you have Bluetooth, Thread, Zigbee, different standards, and of course Wi-Fi. And then it depends on your application, what you want. You have to select. So it's also this part of the design process, what you would like to support, what you would like to talk to, and so on. And of course, if you are really very, very far and from continent level, of course you need to, where you don't have, let's say, LTE or mobile network, then you need to work with satellites. This shows here, I mentioned them, I guess, the pros and cons for each level of network, the local and the wide and the cellular. Of course here, the disadvantages are the battery life because this, of course, if you have it locally somewhere not connected to the power, of course, then also consumes power. Here you have usually high data rates, which you don't have here. No, sorry, here this is the low power. Sorry, low power, you have a low cost, but at the end you have low power consumption, but of course you have a low data rates. So of course this advantage is high data rates, but here you have the high data rates, of course, but it's more expensive. So it depends on your application. You cannot get everything with the same technology. So each technology is targeting certain metrics or certain applications, and you need to know what I would like to focus on. Here I just showed this one maybe a bit, getting a bit deeper into the devices themselves of the gateway. Other things look like. The maybe embedded software guys, they should know this picture, but you have a hardware operating system, and then you have different services here, stacks. For example, if you're talking to sensors, you need to have the stack of each protocol which you are using to communicate with the sensor. Of course, you would need to have a security stack, and of course the FOTA, which is firmware of the over-the-air update. And then you have the data management, because you're having data from different sensors. You need to manage this data, store them, and try to communicate them in a certain way. And of course, you are connecting to the cloud. You have also cloud connectivity manager, and then at the top you have the custom application. This means actually at the gateway you can even have your own applications and make a lot of things without connecting to the cloud if you want. Yeah. If you don't want, of course, you can still maybe run some applications here and at the same time use the cloud, let's say, for, as we mentioned, for non-time sensitive applications. Here to mention, there is one interesting message queuing telemetry protocol, MQTT. It's just a small protocol, publish subscribe protocol. It's mainly used also on that level, yeah, to exchange the data between the publisher, which is the sensor mainly, and the other devices. It can be directly your mobile phone, or it also can be the, let's say, the server itself, whether it's at home or on the cloud. Yeah. Okay, how much time do you still have?
10 minutes.
10 minutes, man. The serious stuff starts now. Okay, can I get more time, or it's just that's okay. Okay, so now I would say now the presentation starts. Okay, so building innovative products. Yeah, it's important here to say products, so building products. So the first thing is product is engineering plus business. So business engineering alone is not enough. Yeah, we need to understand a little bit of this here, because without this we don't have money. We sit at home, right? We need to get money that we get out of home and make the company. Very important. The problem is, yeah, most of us learn engineering very good. We are very excited to technology, but does not work sometimes, most of the times. Okay, so I would like going from idea to prototype, the process. How we should do it. Yeah, you should always start to learn about your audience. Yeah, means the customers, the problems they have. Try to sit with them, try to talk to them, see what are the pain points, what they'd like to have a solution for. It always works. Sometimes, you know, you talk to your family and say, you know, if I would have a device which do this and that, it would be great. Oh, maybe this is an idea. Yeah, try to develop it further. But always try to talk to the person who is your expected potential customer. Construct a point of view based on user needs. Try, after talking to him or so on, try to make an idea based on this, try to make a concept. And then, based on that concrete idea or definition, try to come up with different ideas. You know, like, I can do it in this way, I can do it in that way, I can do it this way. And then after the ideation process, this means the brainstorming, yeah, to get a creative solution, then you need to start implementing this prototype, yeah, building the prototype of your ideas, and then of course you have to test your idea to make sure it really fits and everything. This is the process which is actually not the innovative process, because a prototype is not enough. This is what most people, they think, if I do this, it's nice, but this is not enough. Now we'll see what does this mean. It's very interesting here to say, if you want to build a product, you need to pass through different levels. First, you start with the proof of concept. You have an idea, make proof of concept very fast on MATLAB or whatever, works fine. Then prototype. Prototype, of course, you build something, but of course it's not nice. You cannot use it because it's just technically working, but you cannot show it somebody who can use it and make sure. But then it comes very interesting point. It's called the minimum viable product. This is the most important point, which most people, they don't think about. But this is a very established, let's say, concept now currently in the startup processes. So you need not only to make a prototype. Prototype alone is not enough, because this is still not usable most of the times. You need to make a minimum viable product. You need to make a product which is minimum and viable. What does this mean? This means that you have the smallest thing you can build that delivers customer value. This means any customer can use it and he can give you a feedback. This is the most important thing. So don't focus on a lot of things. Focus on one thing and try to, through this one thing which you are building, which the customer, if he sees it, he feel it like it's product, not a full product, but he can have some features which he can use and give you feedback. He can feel that value, like, oh, nice, you know, it's working. Yeah. Okay, so if you want to build a product, very important that you have to make stuff that people want. We go back to the same issue. That's why we need very important engineering to connect it with the business, especially marketing and, you know, understanding the market, understanding the customer needs. Very important. And this is what this MVP is all about. Now we will see details on how to do this. So again, what it's about, actually, you always, when you start with your product, you have a hypothesis. You have, most probably, I think people will like it. I think this is a big phrase. I think, but does not mean that it's true. It's a hypothesis. The most important thing with this MVP, I would like to go and test this hypothesis. Maybe I'm wrong. Most probably I will be wrong, actually, because I will not get it from the first time. So first, I need to build this MVP and say, okay, if I think I'm right, actually, if now I put it, then people will take it. Then, people are not taking it. There are some problems here. People would like to have it differently. So you are learning, yeah? So the most important thing is that you do something to validate or invalidate a hypothesis or a problem a solution is designed to solve. And it's not a prototype. It's really something valuable for customer. Usually prototype is not functional or something which is more customer oriented. Minimum, as I mentioned, smallest, viable, have usability. It's usable, viable for the customer, yeah. And of course, it's a product. This means something cohesive. It's something which the customer can feel it's a product, not just like 5-6 boards on top of each other and so on. Yeah?
I have just a question.
Yeah.
What is meant with small? Is it the product itself?
No, not the product. The feature set. The feature set has to be small. You don't. Maybe the final product will be 100 features. Focus on the most important 2 or 3 features, let's say, or maybe even 1 feature. Yeah, the most important. Like you feel that if you have this feature, this kills this problem. Like this is the most important thing. Yeah, that's what I mean with minimum. Yeah, small. So this is a very interesting example. For example, this one here is minimum but not viable because this here for rats. This boat is for rats, not for a human being. So you cannot sell a human being because he does not want his rat to go. Right? He wants probably to keep it somewhere else. So. So the second thing, of course, you have a viable and maximum, but you don't have a lot of resources to do this, and you have a big risk because if you do it, maybe you are wrong. Yeah, what you want to do is to make minimum and viable. You make something good enough product to attract the first users. Good enough means that they can use it, you can get feedback, and then from that point, then you go to that with time. We will see it. So. What kind of mistakes happen? Many people think, okay, I would like to build a car. So I'd like first to build, like a wheel and then try to have a chassis and so on. This is wrong. This is not MVP. MVP is you make something which you can use. So from the first time, you have, let's say, an MVP like this. And then you go and talk to customers. Say, oh, nice, but let's say it's not fast enough and so on. Oh, maybe I can make it like this. I'm developing the MVP, but it's always at each stage, it's functional. It's not like just parts. Yeah, they can use it because they can use this one. They can use this one, they can use this one, they can use this one. Yeah? It's very important. So how do you know if you have a right MVP? It's like this. Very interesting. These are the features, or let's say they are characteristics on the MVP. It's feasible, valuable, usable, and delightful. This means when they use it, they will feel, oh, I'm satisfied. And it's usable. Very important, I would say here, usable. Something which can be used. Because a wheel, you cannot use a wheel. Yeah, we want you sit on it, you cannot drive. Right? So,
can you go back to the slide before? I don't really understand the slides because if I define a product with the goals and all of the technical inputs, then I don't say, okay, for the development and the line, it's clear. That if you build up a car and you define it, start with a motorbike or with a bike, it's not really the right thing.
Right. Because
it starts to build up as a car. For example, in 1900s, they start a car with 4 wheels and close up, right? And not with bike.
Right. You can do this, but as I mentioned, you have a big risk. Now, of course, you can build a car because everybody knows what's a car and you know that there is a market for it. But if you are building something very new, you don't know. You don't know, maybe you spend all this time, at the end here you say, oh, sorry, but it's too early for the market, like people don't want to have to pay this amount of money and so on. So you need always to be in the loop, put customer in the loop, especially if you're building something innovative, because we are building innovative products. Yeah, here this process for innovative, not for traditional products. Traditional products, I want to build, of course, does not make. I want to build a table, I go and build the table. I don't need to, go and maybe first make it, yeah.
I think what you mean here is, the goal is you will go from point A to B, right?
Yeah.
You have the line of also development.
Yeah.
Yeah, is that true? Or
Yeah. So you need here to do.
I will only understand.
The point, what I want to say is, especially if you are not aware what your customer needs are. Yeah. If you are building something new, and you are not aware of your customer needs. So the customer needs, if you are building something new, because the customer himself, he does not know even. Sometimes, when you see something, oh, it's nice, but you have never thought like I would like go and buy it. So that's why you need to sit with the customers and get a feedback This is innovate something new, disruptive, new whatsoever. If you have something, for example, traditional people, they know it, then you just go and build it. So and try to get the market share. But of course, you have a lot of competitors, giants, and so on. It's harder. So it depends. But usually here, this is the innovative process. Maybe here it's a bit exaggeration, but in general. So you need to have it functional all the time. It just shows this functionality point. So donuts, practical example, right? So this is what's this food? Not something else. So what's this food? That's not a food, right? It's not a food. So it's not food. Here it's prototype. So this is here. What's this is here incomplete. This is I'm saying this again. Go back here. Don't forget this here. Proof of concept, prototype, MVP. So when you reach MVP, if you are doing coding, hacking, whatsoever, it's not still functional. Still, you cannot give it to the customer, at least to get a feedback. It's when you have the MVP, something which is eatable, because you have to be usable. If I cannot eat it, sorry, I cannot give you feedback. Yeah. So this is very important. Very important to eat it. I'm getting hungry here, I think. Yeah. So MVP, and then of course here you can take feedback, and then this is the end product. Will be based on the MVP, but further developed and so on. Say, okay, here it's too dry, I'd like some sugar and so on and so on. Yeah. So, but that was a donut, the real life application. But let's say here something which is technical, because we are here engineers, right? Not everything donuts. So what I would like to have, for example, is very interesting mobile application development. You start usually with an idea, with a sketch. I would like to make sketch, let's say the interface like this, structure like this, first I do this, that, even with some drawings. You do sketch, and then maybe you can show it to somebody, try to get a feedback, and make a wireframe, then you can make even this mock-up. This is not even the application itself, just like a mock-up of it. There are some visualization for this. So you get a feeling about it. We think, okay, if they try to use it, will they need a lot of time? They try to click fast and so on. There are a lot of course, user experience issues and so on, but just to show you an example. So developing an MVP, what you start with an idea, you build the idea, you get something, code, but it's not necessarily to be code, depends what you are doing. You build, and then you get the code or the implementation, and then you measure, and then you measure, you get the data, and then you learn from this data. This means here this measuring is very important, because you sit with the customer, or you try to get a feedback from the customer. You think, okay, you have missed this, you can add this, you can that, and so on. So you go over and over until you get, like to the point which you need to get to. And here we can see there is something called the MVP core plan. Like it's very important when you're making an MVP that you have a plan also. Like, what are my key assumptions? What's my advantage? Yeah, they call it unfair advantage. What's my big point of differentiation? What kind of features has to be in the solution? Which kind of customer needs or customer problems my product is addressing, and so on. So and of course what I want to measure exactly. When I have an MVP and like to measure what I want to measure, because if you just build it, it's very important to have this, because otherwise you might come to a point where your MVP is like just based on ideas and there's no consistency between them. It's good, write this down, what I want to measure exactly, what I want to show to the customer, what I'm addressing, and then just fill it with text. Here just shows the description, and then you build it based on this plan. Now, the second step is starting with the MVP and customer in the loop. We have this product market fit. This is the most important point. You go back, you see here, this MVP and the product fit. Here you start. Once you get to this point, you can put your product in the market. Before this point, some people, I still remember, some people, they are thinking, or I was also thinking like this before, this is the process. You start to communicate, you get some idea and so on, brainstorming, and then you prototype. But then here you are doing the MVP and you are building measuring and learning, building, measuring and learning, building iteratively until you get to the market fit. We say, okay, now I'm feeling stable, everything's fine, people like it and so on. Great. So here you see the solution space, it takes time. What's very important about the product market fit is that you have your product, you have a proposition, value proposition, you have a value, which you can propose it, and then you can show I have a value for you as a customer. Feature set, and of course user experience, and you have the market. Now, the product and the market have to stick together. If they are not fitting, maybe you are making product for another market. You think it's for the market, but maybe it's for in Brazil. Sorry, you have to go maybe or try to find people there. So it depends. So once you, through this iteration, you make sure that this fitting, then this is the right point. What's happening during this cycle? What's happening during this cycle is that what you are doing is that you are discovering your customers. Yeah, you have customer discovery. You start with certain, let's say, in the market segment, a market segment. Let's say I'm doing something, maybe let's say for students. Yeah, then I start. Okay, I go and show something to students. I develop something to them, and then maybe I can make let's say some interviews, give them some free samples, get feedback whatsoever, and then get feedback and then pivot. Pivot means that you try to tune, tune your device, tune your product in a way that it's more addressing those customers. Yeah? This is called the search phase. Afterwards, it's more execution. Afterwards, after you finish, you have the fit, then you go to the customer creation, you go with full potential, yeah, with the team and everything and so on, try to create more customers and build the company. This shows also details here, very important, but maybe I should skip it because just here also shows that during the customer validation, what you are doing also, you are validating your business model. Yeah, business model also, because based on the changes in the customer needs, or let's say the properties, you are also changing your business model. Maybe they cannot afford the price, let's say. Maybe they don't like this feature, which is too expensive, but they don't like it. Maybe they, so you have to also during this phase also adapt your business model iteratively also as well. And there are also other things. This shows here just business model development and tuning, what you need to think of. I mean, of course, not only the product and the features, but also you need to think about the market, you need to think about your costs, you need to think about how you will get your revenues and all this kind of thing, which actually usually for engineers mostly they are thinking about, yeah, it's working, yeah, but it's working for you, but maybe not for somebody who will pay for it. The question is, are they willing to pay for it or not? And of course, I will not dig to the details, but it's very important to also see how I can, get this to the customers, because if you want to scale, you need to have, distribution channels. You cannot just, send by post and so on yourself. So that's also very important to think about the business model iteratively and tune it and so on. Develop it and tune it. Now the question is, as I mentioned, when do you know that you hit the fit? Yeah, there's a very interesting example with two products, product A and product B. Product B, let's say you start here, you made marketing and so on. Product B was 100%, but it's dropped because this means that you are not really addressing the customer needs. There's something wrong. But customer A, dropped, but then stabilized, because it's always in the beginning, it's a hype, like it's always like big, but then stabilized, but then you still have really good customers here. They are still, there's orders they are requesting and so on. Okay, if you don't have, I would like to talk about startups, but if we don't have time, then we can stop.
I have time.
Okay. A few slides just about startup. So who would like to build a startup here, or who already have?
Everyone.
Man, we need. Be strong, man. Who wants to build a startup? Why you are afraid? If you are afraid, you cannot build a startup. Okay. Okay. So you want to build a startup. So what's important? I think it's very interesting. Interesting picture about the startup development phases. So first, what you do is you do ideation, and then you make concept, and then this all pre-startup. This is not yet startup. Yeah. Actually, it's very interesting. The growth here, it's minus. So this means here you are just spending time, and maybe money, and maybe some coffees and so on to do this. Now the point starts really once you have a good concept and you make the commitment. This is the zero time. Yeah. This means all you are discussing with your friend things. No, this is blah blah. Good, but maybe let's see. So once you make the concept here and you have a commitment, here this is 0. We just started, commitment. And then directly you need to work for, get your MVP. Work, implement it, and so on. Plan MVP. If you don't have an MVP, you are still here. MVP is just the beginning of the startup, the first phase of the startup. And then after the MVP and iteration, then you get to the market fit. Yeah, you see here different tunings and so on. You see ups and downs and so on, communication. You get the fit. Once you get the fit, afterwards, then you can think about creating customers and scaling. So this is, they say, most of the people, most of the startups, they die in this phase. Yeah, in this here. Yeah, in this mainly here. Oh. Because what they do is that they concept, a scale. A lot of customers I want to make. How can I bring it? No, you cannot think about here. Scaling here wrong, because here you are like killing yourself. A child, he makes step by step. You cannot just get him directly 20 years. Grow step by step. So what you do is that you have to make this. If you don't make this, most probably you will die. You will die. So, and that's why we'll see also why startups, the failure they do. Now in the next slide, scroll. So this is when you start to get sales and profitability. Because maybe, for example, they think, I want to build something, I'm not getting money, I'm not selling, I'm making. Just wait, because this takes time. Yeah, this takes time. So this is here time to market. You get into the market, you are investing, you are exploring. We said this exploration, MVP, and so you're paying money. Of course, you have to invest. That's why it's very important that you cannot just say, okay, I will, if you can get some funding would be great, because it also will cost money. You have to implement, you have to get people feedback, and you have maybe to sit with them, give them some free samples whatsoever. So it costs some money here to build the prototype and MVP. But even if once you go to the market, also it will take some even time until your sale will ramp up, because you will directly get the sales, or people would like to have your products. So they start to say, oh, it's nice. They make like evaluation on the internet, whatever. People say, like it, maybe tell their friends, they so on, and then it takes time until it gets growing. So this means that you have, this is called the break-even point. Yeah, break-even point is there when your investments are exactly equal to your cost equal to your return. This means that you are not getting any profit. Yeah, then you start from here on, then you will start go up. Yeah, and then go down. Of course, every product will die at some point. So you need always to get another product and so on. Yeah. So here after the market, of course, sales starts here and then step by step. So this is very interesting. I think it's like the summary. You start with market attractiveness. That's why you start always with the market. That's why I showed you the IoT market. Yeah, you understand there are different IoT sectors. Where do I think my idea fits? It's very important. You start always with the market. You don't start with just sitting and dreaming and of just technical stuff. Yeah? It has to have a market. Since it's good if you have a market research and so on. You need to understand the market attractiveness, and then customer problem fit. Yeah, there's a problem the customer have. I would like to find a solution for it. So this means I have a customer problem fit. Then I have a problem solution fit. I have the idea which fitting to this problem. So I can have the fit between the solution and the problem. And then this is the MVP mainly. Yeah, and then after that I'm having product market fit. So I make sure that my product which solve this problem is actually will be bought by customers. They would like it. They will pay for it. I will have success. I will have profitability. Yeah, because no profitability, you go home. Don't forget this. Yeah, and then of course here you will have a really very, very clear business model. You will develop this with time, but let's say here very clear business model fit, and then here you scale and grow. So there's a lot of steps. A lot of steps, you need to understand them so that you are not too fast and think, oh, I'm not doing it. No, it takes time. Yeah, takes time. Do it step by step. The most interesting thing in this picture is scaling. So here maybe you are 1 or 2 persons. Yeah, but once you go up, what's going on? Your product development, marketing, sales, team size, organization all grow. Yeah. So here you are small and then you are growing as an organization. Once you go up, so you cannot start with, because you are still making the prototype and MVP. Yeah. Problem idea. But once you start to have product market fit, you want to get to the market. You need a team. You need sales. You need marketing. You need really to push. Yeah. Full potential. That's why I like this very interesting summary here. It just shows the same thing, but I like it here more because here it also shows the strategy development. Once you know your product market fit, you can think about your strategy, where you are positioning yourself in the market. Yeah, we have competitors. What's your like portfolio? What's your pricing? What's also tuning and so on. And then of course you realize the business model, and then you scale also. So this I think is very interesting strategy point here. Yeah? So this is the last slide. I find it very interesting. 20 reasons startups fail. Yeah, we will take maybe the first 3. No market need. Yeah, no market need. Easy. He's sitting, playing, and so on. Very nice application. Look, it's moving and so on. Exactly. No market need. 42%. Yeah, almost half. Run out of cash. Also very important. You have to be careful. You have to know what's your cost and so on, even if you are building the MVP and so on. But this is also very, very important, not the right team. Yeah. Some people, this is also a big problem. They, go, let's make a startup. How are you? Are you fine? What's your name? Let's go make startup. Let's go make a startup and say, oh my God, man, I cannot work with this guy. He's not working. He's doing this and that. So never ever start up with a person you don't know for a long time also. My proposal. Because once it gets to money and stuff like that, you will see a lot of interesting things. Yeah. So exactly, and of course you have to be careful of competitors and so on. But I mean, you can read this alone. So, but what's important? The market. You need to understand the market and work for it.
The percentage makes no sense. It's not 100%.
It can be. Maybe there are some miscellaneous here, small percentage. No problem. You don't have always to be exact, because you will not be able to build the MVP. You have to have tolerance. Yeah. So, but there's a source here. You can send them the email and tell them it's not a person. No problem. Okay. So, if you have any questions, please let me know. I enjoyed the presentation myself, and that's enough.